Hello and welcome. In the last video, we talked about evaluating limits from a graph. So looking at the graph of a function and determining the limit and what the limit is. In this video, we're going to look at the function and how to evaluate a limit using direct substitution. So our goal in this lesson is that I can evaluate limits using direct substitution. Let's go ahead and jump right in. So in the last lesson, we looked at graphs of functions, and if a function was continuous, meaning if I hadn't lifted the pencil up for my particular function, if I was looking for the limit, I could just look at the exact value of the function when I was looking at the graph. So if a function is continuous at some value, x equals c, it is guaranteed that the limit is just going to equal the value of the function. So we're allowed to just plug the value in and simplify. What this basically means is if a function is continuous, plug in the number and simplify. So if we look at these two examples on the right-hand side, 3x squared minus 5, well, that's a quadratic, which we know is continuous, and we know we can plug 3 in. So if we plug 3 in, we would get 3 times 3 squared minus 5, or 27 minus 5. And I want you to go ahead and rewrite the limit statement. The limit as x approaches 3 of 3x squared minus 5 is going to be 22. So if our function is continuous, we can literally just plug the number in. If you look at number 2 isn't continuous everywhere. We know we're not going to be allowed to plug 3 in because that would make the denominator 0, but we're being specifically asked about the limit as x approaches 1, and we can just plug 1 in because at 1 this function is continuous. So if we plug 1 in, we would get 1 squared minus 3 times 1 over 1 minus 3, which is just going to be negative 2 over negative 2. So the limit as x approaches 1 of x squared minus 3x over x minus 3 is going to be equal to 1. Let's look at a couple more examples. All right, all of these functions are continuous at the values that we are finding the limit of. So you're going to plug in that limit value or the number below the limit as x approaches into the function and simplify. Go ahead and pause the video and work through these on your own, and then unpause the video and see how you did. All right, hopefully you had time. This is going to be cosine of pi over 3, which is 1/2. And again, I just would like you, personal preference, to rewrite the entire statement saying what that limit is equal to. Just make sure you answer the question. Number 4 is a little weird because there's no x value happening, which actually means we can just take this scalar and move it in the front, and as x approaches nothing, there's nothing to plug anything into, so this limit is just going to be equal to 3. So the limit as x approaches 0 of 3 is 3, because there's no x value to substitute in anything anywhere. For number 5, we're looking at the value of what happens when tangent is pi over 6. And we know that tangent is the same thing as sine over cosine, so sine of pi over 6 over cosine of pi over 6. On the unit circle, that would be this coordinate out here, which would be root 3 over 2, 1/2 cosine sine. So we're going to go ahead and do this division, 1/2 divided by root 3 over 2. We're going to flip and multiply, so this is going to be 1/2 times 2 over root 3. And then don't forget you need to rationalize that denominator, multiply by root 3 over root 3. So all this to say the limit as x approaches pi over 6 of tangent of x is going to equal root 3 over 3. And last but not least, if I plug 1 in here, I'm going to get 1/3 plus 4, or 1/3 plus 12 thirds, right? 4 is 12 thirds, which is going to be 13 thirds. And I'm going to rewrite that limit statement. The limit as x approaches 1 of x over 3 plus 4 equals 13 over 3. So let's go ahead and wrap up this video. So our goal in this video was that we could evaluate limits using direct substitution. This property only works when the function is continuous. In the next lesson, we're going to talk about what to do if we can't actually directly substitute in because we don't have continuity. So go ahead and write down any questions you have, and I look forward to supporting you on this. Thanks for listening.